In this capstone, we bring individual controls together into a working architecture. The goal is a defensible layered design that connects identity, data, models, APIs, infrastructure, monitoring, and governance. So secure AI can move from concept to implementation. So far, we've built the architecture layer by layer: identity, secure applications and data, cloud workloads, and governance. Now we connect those controls into an enterprise AI design that can be reviewed, operated, and continuously improved. The reference scenario is an enterprise AI assistant used through web, chat, or APIs. It retrieves answers from internal documents, policies, tickets, and operational data. It may also take bounded actions, such as creating a ticket, summarizing a report, or querying a business system. That convenience creates risk. So identity, authorization, data protection, prompt controls, API security, workload security, logging, monitoring, and governance all need to work together end to end. Before selecting AI security controls, define the operating context. Start with the business outcome: improving productivity, automating support, discovering knowledge, or assisting developers. Identify the users, including employees, analysts, admins, service accounts, and partners. Classify the data, especially regulated customer, employee, source code, and telemetry data. From there, translate the context into access expectations: least privilege, separation of duties, need-to-know access, and auditability. AI requirements define what the assistant may retrieve, which models it may call, how prompts are controlled, and what actions it can take. RAG requires approved sources, indexing rules, embeddings, vector store boundaries, and freshness expectations. Model deployment needs clear patterns, from hosted LLMs to private or routed models. Prompts need templates, guardrails, and change approval. Agents need tool permissions, execution limits, confirmations, and logs, because generation can quickly become action. Deployment is more than an infrastructure choice. It sets boundaries for security, compliance, and operations. Managed AI services can reduce engineering burden, but may limit control. Self-hosting gives more control, but adds responsibility for patching, monitoring, and resilience. Hybrid or multi-cloud designs can address residency or availability needs, but they also increase complexity. Capture these trade-offs early, including latency, recovery, logging, identity, keys, and platform dependencies. Secure AI works best as a layered system, not as a single control. Identity proves who and what is connecting. Application and API controls shape the session, validate inputs, enforce authorization, and slow abuse. The AI layer adds prompt defenses, retrieval filtering, model permissions, agent boundaries, and output checks. Data, workload, and infrastructure controls provide segmentation, encryption, logging, and resilience. Governance cuts across every layer, making responsibilities visible and controls auditable end-to-end. Identity is the first control layer because every request needs a trustworthy subject. For people, that means SSO, MFA, passwordless options, conditional access, and device posture. For systems, it means separate identities for apps, agents, pipelines, workloads, and admins. Authorization then determines the allowed action using RBAC, ABAC, or policy-based rules. Secrets should be brokered, rotated, and short-lived through vaults, KMS, HSMs, and workload identity, so the design does not depend on static keys. At the application and API layer, security moves closer to user intent. The application rejects malformed input, protects sessions, and detects abuse before requests reach core services. APIs enforce identity, authorization, schemas, quotas, and token scope. Workflows add prompt inspection, instruction isolation, content filtering, jailbreak resistance, and response validation. When agents can call tools, treat every action as privileged. Allow list tools, check policy, require human approval when risk is high, sandbox execution, and log everything. Layer 3 is where AI security becomes operational. The goal is to protect both what the system uses and where it runs. Data controls cover classification, encryption, masking, retention, lineage, and leakage prevention. RAG needs extra care because retrieval must respect source permissions, protect embeddings, isolate vector stores, and log access. Cloud, Kubernetes, and container controls harden the execution plane with segmentation, private access, image scanning, admission control, runtime detection, backups, and secure egress. Layer 4 makes the design accountable. Evidence comes from authentication, API, and prompt activity, data access, retrieval, model calls, agents, and admin actions. Monitoring uses that evidence to detect policy violations, anomalous prompts, sensitive data exposure, failed authorization, and unusual agent behavior. Controls are validated through tests, configuration checks, reviews, red teaming, and simulations. Governance closes the loop by approving model, prompt, dataset, and policy changes, while tracking exceptions and attestations. Secure architecture is rarely about perfect control. It is about documented trade-offs. Choices like managed services, private endpoints, broad retrieval, narrow retrieval, automation, or human approval all change capability and risk. For threats such as hallucination, prompt injection, leakage, or privilege misuse, define likelihood, impact, control strength, detection, and business tolerance. If the ideal control is too costly, slow, or incompatible with legacy systems, add compensating controls and record the residual risk for explicit acceptance. Strong AI governance turns design choices into repeatable operating decisions. Every new model, dataset, RAG source, agent tool, privileged access path, release, or policy exception should enter a formal review. Accepted risk needs an accountable business owner, security sign-off, compensating controls, an expiration date, and a review cadence. The work then continues through backlog improvements, outcome monitoring, and revalidation after incidents, red team findings, regulations, model upgrades, or major process changes. The capstone deliverable is more than a design document. It is a review package that helps every stakeholder make a decision. Diagrams show how data, identity, networks, AI services, and admin access actually work. Control matrices show that requirements are covered. Threat and risk summaries explain what was accepted, mitigated, or still remains. The roadmap assigns owners, validation steps, audit evidence, and runbooks. When these artifacts are clear, the architecture is ready for governance review. Secure AI operations come from layered design, not isolated controls. Let requirements drive decisions across identity, data, models, agents, cloud, and monitoring. Document trade-offs, residual risk, and approvals clearly. The next step is to turn this framework into reviews, threat models, validation, and continuous governance.